Hello again. In this new video, we are going to continue with our examples of assembly programming for the AVR. So far we have done a very basic program. We have seen the right way to do it in AVR assembly, and we have used the toolchain directly, the GNU AVR toolchain directly, executing the compiler and the debugger, simulator, and everything. So normally we'll want to use an integrated development environment, some kind of interface to the tools. Okay, for the AVR family there are different options. So we can use the raw tools in the tool chain as we have done, but we also can use a makefile system. Make is a system to automate a program execution that comes from the Unix operating systems, and there are options to do that in Unix systems like Linux or Windows. Okay, and another option is to use a more integrated environment. So the official environment for AVR design is the Microchip Studio, which is the former Atmel Studio software. It's an integrated development environment based on Visual Studio from Microsoft. It is the Visual Studio suite, not the Visual Studio Code. Okay, it runs in Windows only, and it includes different options for using toolchain, different kind of projects, and so on. It's pretty much complete and has a very nice debug interface. And now from the free software world, we have Platform IO. Platform IO is a system which is designed to develop software for embedded systems, and it supports many different platforms, including the AVR platform, and basically does the same. It solves the problem of installing the toolchain and interfacing with the debugger, and also simplifying the writing of code. And Platform IO also have an integrated development environment that works with Visual Studio Code. And so you can, if you have an installation of Visual Studio Code, you can ask Platform IO as an extension, and it's not as advanced as the Microchip Studio IDE, for example. But if you are used to programmers integrated development environments like Visual Studio Code, it's a nice option to use. So in this video we are going to do the same example as in the previous videos, but using Platform IO, and basically the same tasks: writing our code, debugging, uploading to the board, and everything. Okay, so in Ubuntu, Visual Studio Code can be installed from the Ubuntu Package Manager. In the Ubuntu Software Package Manager, you can search for it. You search for code or VSCode, and here it is. It is distributed as a snap package, and just go and install it. And once we have Visual Studio Code installed, we just install Platform IO as an extension. Okay, and what we are going to do is just use the same example we have done in previous videos, but we are going to use it, convert it into a project of Platform IO. Okay, so let's start with the Visual Studio Code thing. Code is here. You know, you may know VSCode. VSCode is the same free base of Visual Studio Code, but it's an independent compilation. It means that while independent compilations are free software, the Visual Studio Code product from Microsoft, even if it is the same software, is not free software. Unfortunately, today Platform IO only works, at least it only works legally with the Visual Studio Code compilation from Microsoft, not with the free alternatives. Okay, it can be solved. It's a technical problem. It may be solved in the future, but for now you have to use the distributed version from Microsoft. So this is a fresh install. You have plenty of messages here. Okay, we'll try to go directly and do all the configuration. And here we have the extensions. This kind of programs, these type of programmers development environments are well known because these are very flexible in the sense that the program does some basic things, but most of the functionality is obtained by installing extensions. So we go for the Platform IO integrated development environment here. We install it. Once we have Platform IO installed, it will take charge of installing the tool chains on the tools you have to use to develop in any platform you select. So you don't need to install the assembler or compiler or anything for the AVR platform. Okay, the Platform IO will take care of the details for you. So this is the first run, so now it's downloading things. Okay, okay, now we have a message here. There's some package we don't have installed. Okay, so it says to install this package, okay, the Python 3 VM, which is for creating virtual environments for Python. Okay, so we'll copy this and we'll open the terminal. It haven't happened to me before, probably because I already had that packet installed already. Okay, so sudo apt-get install. So what I'm going to do now is that I will probably uninstall it and install it again, okay, just in case. Platform IO. Okay, let's go and try to install it again. Now it's finished. We have to reload the editor. Click reload. Okay, now it's fine. Now, because we are going to develop for the AVR platform, there's another extension that is useful. We look for AVR, is this AVR support, okay, assembly language support. This is used to, it's an extension that provides syntax highlighting for assembly code. So it's nice to have. We're going to install it as well. Okay, now it's done. Now, once we have Platform IO, we have this icon here, okay, with the Platform IO menu. Platform IO is a very big extension, actually. So we are going to start by creating a first project with Platform IO. So we can go here to home. We can I think we go to open and it will load the interface. Okay, and you see it's a very complex extension actually. Okay, and you can develop for many different platforms, not only the AVR, for different microcontrollers and using different tool sets. It's a bit complex, but for us it's not that difficult. First thing we are going to do is that we are going to create a new project, so you see how it works. And our project is an AVR assembly code project that we want to run in an Arduino Uno board. So we go directly here and we look for Uno, okay, Arduino Uno. It will select for us then the framework and the tool chain that we have to use. We give it a name. We are going to call it example 1AB, and that's it. If you see this framework, the framework means the set of tools and libraries that you have available to develop for that board. Okay, by default, Platform IO uses the Arduino framework. It means that it will create something like an Arduino project. Arduino is a framework to develop for the Arduino boards that uses lots of libraries to make programming these microcontrollers in a very easy way. So it will create an Arduino project with the files typical. Yes, for that. Okay, we are not interested in creating an Arduino project, but we will see how to transform this project for Arduino in something more simple, the thing we need to program directly in assembly language. But it is important that the first time we create a standard Arduino project, because it will make the platform to install all the libraries and all the tool chain we need to develop for that. Okay, so Platform IO works like that. This is our new project. We have a configuration for our project. It selects the platform is Atmel AVR. It basically defines that the tool chain is what we already have seen in previous videos, is the GNU compiler, debugger, and everything. The board is the Uno, so because of the board, the platform knows how to program it, what tools it needs to compile the code to program it. Okay, so we don't really have to know the details, and this is the framework, which is the set of libraries and other tools we need to program that. Okay, so how and where do we put our code? In the source directory here, it creates a template file, main CPP, because Arduino projects are programmed in C++ language. Okay, so it creates the typical structure of an Arduino project, a setup function and a loop function. Okay, so if you want to program like Arduinos, if you already have experience using Arduino development environment, you can use this Platform IO as your Arduino development platform. It's perfectly fine. So from here you can go there, but we are not interested on that. So first thing we are going to do is that I have a repository explaining how to transform it. So let's go and check that. Is this a Platform IO template for an AVR project. It means a project that uses the toolchain directly without any framework, not Arduino or anything. This is how you can configure your project in Platform IO to program in assembly language or in C language directly. Okay, so this repository itself is the template. You can download the repository and as a zip file and compress in any folder, and then you go here and then you have all the files. Okay, or this is the quick start. described here, it will work if you have previously run or created any previous Arduino project for the system to set up the toolchain. Okay, so that's an option. You can download the folder, uncompress, and then you have everything set up. Or you can, the alternate thing is to do it a bit manually. Okay, we are going to do it manually because we have already started our first project. So what we have to do is that we go to our configuration, project configuration file here, and we make a few changes as it is described here. Okay, the changes are really simple. Okay, basically what we say is that we don't want to use any framework, so we can comment out or we can delete this line here. We don't want to use the Arduino framework. If we comment it out, the system will just use the regular set of tools, the tool chain as it is. And now we normally want to debug our programs using a simulator. So we add this line here. We say that the debug tool is going to be the sim AVR simulator, as we have done in the terminal before in previous examples. Okay. And then we want to, when we simulate our devices, it is possible to create an interface to the peripherals registers. So we have an easy access to the peripherals. We don't have to display the memory content to look at them. Okay, so in this repository, we have prepared a file with the definition to make it easy to access the peripherals. And then you can put this one. It means that this is the debug option, which is this SVD file. Okay, so this is a configuration for the Arduino Uno or for any project that uses the ATmega 328. Okay, so this is our small bits. Now this file we have to download. It is here in the repository, so we can go here and actually we can download the whole repository. We can open it in the archive manager, and we can copy this file to our project folder. Okay, where is it? So we let me see, I think it's in the home page. I don't remember where Platform IO actually. Here in documents folder, Platform IO creates the full folder for the projects. Okay, so this is the folder for our project. So we simply copy that file here. Okay, so now we have update the configuration for the project. We have the file defining the peripherals, and okay, and we have our here we have our C++ file. We don't want to program in C++, so simply we change it to main.s, uppercase S, and it's going to be our assembly language file. Okay, and what we include here is that, well, we had in our previous examples. Okay, we save the file and this is all set. Okay, once we have that, I will recommend to close the thing, okay, and reopen it again, because we have changed some configurations here. It should not affect, but if you have problems, you may close everything and open it again. Okay, I will try to follow as it is here. Okay, so now it is set. Now we have our file here. Just to check how it works, what I'm going to do is I'm going to copy the code from our previous example. You see, I will copy exactly the same code. Okay, you see we have some syntax highlighting because it detects it's an assembly language file, okay, but it's a standard assembly. It's not AVR specific. So if we click here, we because we have installed the AVR assembler extension, okay, we can select this and it will make a better syntax highlighting in our file. Okay, now up to now, now we have a very advanced editor to edit our code. Now, what can we do? We can do everything. If we could go to the Platform IO tab here, we see all the tasks we can run in our project. So remember, previously we ran the simulator or the assembler manually. Okay, now it is here in the build link here. If we press build, because the system already knows what is our board, it knows what is the toolchain it has to use, it will execute the assembler or the compiler for us automatically. Okay, so to make the compiling, we just press build and it will tell us in a terminal here what it's doing, and will tell what's the result. Okay, so it has generated a program of 150 bytes and that's it. Okay, now we can upload to the board. It knows about the AVR dude command. It knows what are the options to the command. It knows everything. It knows the which board we are using, okay, the Uno, and so it knows all the details. It's already programmed there, so we can upload our program right away. So we are going to do that. Actually, in the previous video, we did the program, we debugged the program, we executed the program in a debugger, but we actually did not test it in the board. So we can try to do it from here. So let's come here and let's click on upload here. Okay. Oh, let's see what happened. Okay, it's not working very well. Okay, it's not working because I'm using a virtual machine to record these examples. So I have my board, but it's not connected to the virtual machine. It's connected to the real machine. Okay, I'll go to my virtual machine options and just connect the board to the machine now. Okay, normally Platform IO will detect automatically at which port it's connected. So I will repeat the upload. Now you see the LEDs blinking in the board, so it should be running now. Okay, and we can test if it's working or not. So my input is in ground here, so it's the output is 0, and if we unplug the cable, okay, the LED here will light. Okay, we don't need to connect it to the power rail because we have a pull-up activated here. Okay, so it's working fine. So imagine we don't have the board, and so we want to simulate it as we did in the terminal in previous videos. So we also have the debugger interface here. Okay, so if we go here, automatically Platform IO has created some debugging configurations for us. It means that we just have to click in a PIO debug and it should run the debugger. Okay, and now we click play here and it will run the debugger in the background. Okay, it's not working very well. You see, it's running. Are the debugger controls, but it's not really working. Okay, this is the glitch I told you about. Okay, finally it makes an error here. Oh no, I think it's working. Okay, I had a problem in my computer, but it's working here, I think. Okay, So it's interesting, if you have seen the previous videos, that the debug console is actually the console for the GNU debugger. Okay, you can write commands here to print and set things and write set breakpoints from here. Okay, but this is captured by the interface, so we have a nice interface here. Okay, so these are the debugger controls. We can move it here. And from these controls, you can continue the execution. You can step one instruction and everything. Okay, you can restart the simulator. You can stop the debugging session. And here we have many things here. We will close all these, and here we have the peripherals. The peripherals are not showing. Yes, I don't know what the problem is. Okay, so let me check. Maybe we have to do, as I told you before, we have to get out of the editor and get in again. Okay, so let me stop it. We will close the project, close everything. Let's run it again. It's not really a problem if we find some problems, because the idea is that you may run into similar problems actually. Okay, so you see it opens the same project again, and we'll go to the debug interface and let's run the debugging again. If you see, it will compile the project again every time you debug it, because normally it uses different options to compile for debugging or not. You see, this time it is here. Okay, you can see the ports here, so it's a bit easier now. Remember, our program will read 1 bit from port D. It will actually from pin D, pin number 7 here, and we'll write pin 5 in port B, which is pin 5, PB5 in port B. Okay, so these are the bits we are interested in. Okay, this is the input, this is the output. So we can stop debugging. We can use shortcuts. It's very interesting to learn the shortcuts. Okay, you can step over or step into. They are similar here. They are the same, F10 or F11, just to go one step at a time. You can also set breakpoints. Breakpoints are set just by clicking here and this side here normally. Oh, we need to activate an option for that. Okay, I'll do it in a minute. And if not, you can just press F11. Okay, so we have set port D PD7, port D clear this one, so you can check here. Okay, this is port D. Here we have set port D bit number here. Okay, port D bit number 7, so the port now is 80. If you want to see the bits, we have set bit number 7 in port D to configure it as that bit to configure the pull up here. Okay, we set the port 5 in port B here. We are going this here. We are going to set this bit here. Okay, just to make it an output. Okay, so execute the instruction and we see it's set. So that way we can check that it's working correctly, and you can see how it changes. Okay, so you see PB5 is 1 because PD7 is 1. Now, if we want to change the value of PD7, you can do it in 2 different ways. You can use the GNU debugger console as we did in the previous example. We can say set a pin d equal to 0. So we are going to pin d, set all the bits equal to 0. Okay, that's it. It's not refreshed here immediately, okay, but it's done, okay? It's done in the debugger. So if we continue the execution, now it's refreshed here, and then this is 0 now, so the port B5 will change to 0 the next time it's checked, okay? So this is a way to do it, but we can also edit the value here in the menu here. If we update the value, this is a 1 bit, we can set it to 1, okay, and then we can continue the execution, and next time it's checked, port B is changed to 1, okay. And in the same way, we are not using the registers here, but we can check the registers values, okay. We can also here print memory. We can put that memory address. It will open a window with the memory portion we want to see. We will see in following examples. Also very interesting is the watch. The watch is very similar to the display. If you remember, if we want to display, for example, we want to display pin D as we have done in previous example, and we want to display port B, okay, so we can see the input and output, okay. You know, we can do it in the console here, and it works as when done in the terminal. We will have this information, okay, pin D and port B printed here. But the watch is similar. We can add an expression here. For example, we can write port D or pin D, okay, and we will have the value of the expression all the time here, and we can put port B, for example, okay. So we don't have to see all the peripherals and scroll through the peripherals and so on, because we can watch here the information we are interested. So normally we may try that. Unfortunately, right now Visual Studio Code doesn't have a way to select the format of this data, okay. So we can remove the expression, but we don't have a way to do it. Note that we can do any expression we like. For example, we have pin D, which is 128, because this is the 7th bit. We may want an expression that makes it more easy to understand. So we can see pin D, and we can divide by 128. So this expression will be 1 when the input is 1, and will be 0 when the input is 0, okay. And the same for port B. We can say we want to display port B divided by 32, so it is easier to check, maybe, if you prefer like that, okay. So as we execute our program, we can do that. And if we want to change the value, we can do it as we have done before, okay. So our expression is updated. So normally this peripheral view, this is okay for simple examples, but when you try to debug complex programs, you normally want to define your watch expressions just to have the information ready of exactly what you want to check, okay. Okay, so so that's it. This is an introduction on how to use the platform IO development environment. So what do you have to do if you want to create a new project? You don't have to go through all these steps, okay. If you want to create a new project, you can, let's stop the debugger first, and let's close it. So if you want to start a new project, you are in the platform IO projects folder, you can just copy an older project, okay, or you can just download the I think it's over here, not here anymore, or now you can just go to this template repository, download it as I have done before, okay, open with an archive manager, and then you can copy it right to your computer and change the name. Okay, my new project. Okay, and you are set. Okay, here you have everything ready. You have a source folder with your source file. These are compiled. You don't really need that. And then you have everything. You have the platform IO file already configured. Okay, it has the configuration and have comments with other interesting configurations that are possible, but basically you are set just by copying the file. Okay, but the first time it is nice that you do it a bit more manually so you understand what you are doing. Okay, that's it. Thank you.